This video is for class 9 physics and today's topic is variation of atmospheric pressure with altitude. The atmospheric pressure decreases with altitude mainly due to the following two factors. Number 1, the first factor, decrease in height of air column, which causes linear decrease in the atmospheric pressure. It means as we are going up, right, the pressure on the object decreases. Number 2, decrease in density of air, which causes non-linear decrease in the atmospheric pressure. Why non-linear? Because here you can see here, right, the decrease in density of air with altitude is non-linear. The decrease in density of air with altitude is non-linear. Let us try to understand this. Going to the next page, first line, the atmosphere can be considered to consist of number of parallel air layers. Each layer experiences a pressure on it due to the thrust or weight of the air column above it. Therefore, as we go up, the height of air column above us decreases, and so thrust exerted by the air column also decreases, which results in the decrease in the atmospheric pressure with increase in altitude. Okay, let us try to understand this. Let us consider a surface of the earth. Okay, and on top of it there should be atmosphere. First layer, second layer, third layer, and the fourth layer, right? So suppose there is one object lying on the surface of the earth here. So this object will feel pressure because of all the layers of atmosphere, that means this height, right? So as we go up, or as the object moves up, suppose the object reaches here, then you can see the air above it also has decreased. Okay, so the object will feel less pressure here, less pressure, right? Pressure, okay, it will feel less pressure. Now again, if the object moves here, obviously the height has decreased again. So since the height has decreased, it will feel more less pressure, right? That means the pressure decreases as the altitude increases. So as the altitude ALT, as the altitude increases, pressure decreases. I hope you understood the first paragraph. Let us try to understand the second one. Coming to the next point, since the lower layers get compressed due to the weight or thrust of the upper layers, as in the previous diagram you must have seen that there were so many layers, the lowermost layer will be pressed by the upper layers, right? Therefore the density of air layers is more near the earth's surface, and it decreases as we go higher and higher. The decrease in density with altitude is not linear. It is not linear. Remember, it is not linear. That means it is not uniform. It is rapid at low altitudes near the sea level and slows down as we go at a higher altitude. That means the amount of decrease near the sea level is much more than the amount of decrease at the higher altitudes. So due to the decrease in the density of air with altitude, the atmospheric pressure also decreases with altitude, but in a non-linear way, because the density is decreasing in a non-linear way. Figure 4.22 shows the variation of atmospheric pressure with the height above the sea level. At Mount Everest, the atmospheric pressure is only 30% of the atmospheric pressure at the sea level. So here you can see the curve goes down, right? The curve is going down here. Okay, as the height increases above the sea level, the atmospheric pressure decreases, right? But it is not linear, it is non-linear. Okay, right. So I hope you have understood till here. Okay, let us go to the next paragraph, consequences of this decrease in pressure. Okay, as we go to a higher altitudes. At high altitudes, since the atmospheric pressure is less, breathing becomes difficult and nose bleeding may occur due to excess of pressure of blood over the atmospheric pressure. Therefore, high blood pressure patients are not advised to go to hill stations or to the higher altitudes. Number two, at high altitude, a fountain pen leaks. The reason is that the fountain pen filled with ink contains some air at a pressure equal to the atmospheric pressure on the surface of the earth. So when the pen is taken to the high altitudes, much higher altitudes, right, atmospheric pressure at the altitude is low, so the excess pressure inside the rubber tube forces the ink to leak out. Okay, I hope you have understood this. Thank you so much.